Hey everybody, this is the notes for the binomial theorem, so make sure you take good notes, pause, rewind if you ever need to, and jot any questions down that you might have, and let's get rolling here. Definition right there to begin with is the binomial theorem is a shortcut, very quick way whenever you need to multiply a binomial by itself over and over and over again. The foundation is that you can use coefficients in a binomial expansion. It comes from Pascal's triangle. We'll talk about Pascal's triangle in just a few moments here. So how you build it, each number of the triangle is the sum of the two numbers directly above it. A little example, if you want to get the row to the 6 in the row 4, you're going to add the 3 and the 3 above it to get that right there. Let me show you what I mean by that. If we go through and we have this idea of Pascal's triangle, the tippy top is a 1, and then the outside is 1, 1. All right, that's kind of how it begins, and then you kind of keep adding more and more rows underneath of it. Then we have row with this 1, then this 2, then this 1. You might be like, okay, well then what happens? You always start with a 1, and you always end with a 1. But then the middle numbers are always found by adding the two numbers directly above them. So 1 right here plus the 2 equals a 3. This missing spot right there would be the 2 plus the 1 to equal a 3. And that right there would be row number 3. You might be like, whoa, Mr. Reidner, let's pause right there for a second. I started at the tippy top. This is technically row 0. Then I had row 1. Then I have row 2. And the reason why I do that is because the second number in each row will tell you what row number you're on. All right, well, let's take a look at another one here. How about if I start with a 1 and I end with a 1? Every single time, that's how it works. Then the middle numbers are always found by adding the two numbers directly above them. So this 1 plus the 3 gives you a 4. This 3 plus the 3 gives you a 6. And this 3 plus the 1 gives you also a 4. So that is row number 4. Looks like 1, 4, 6, 4, 1. Sweet. Let's take a look at another one here. This is going to be row number 5. All right. And we always start and end with the same number, which is always going to be number 1. All right, the 1 plus the 4 gives you the 5. The 4 plus the 6 gives you a 10. The 6 plus the 4 also gives you a 10. And then the 4 plus the 1 gives you a 5. Awesome. Let's do another one. How about row number 6? Always start and end with the same number, which is always number 1. 1 plus 5 gives you a 6. 5 plus the 10 is a 15. 10 plus 10 is a 20. 10 plus 5 is a 15, and 5 plus 1 is a 6. You can keep going over and over and over again. It doesn't ever end. And there's lots of cool properties that kind of help you out with this. But what we're talking about today is the binomial theorem. So what this means here is if we're looking at whatever power we have. For example, I don't know, maybe we'll do to the power of 4 right there. And if I had the Pascal's triangle 1, 4, 6, 4, 1, if you need to see how I got that, just rewind the video a little bit. And if I look at this expanded form, x plus y to the nth, that means x plus y to the power of 4 actually equates to this right here. Now you might be like, how did we get that? One way that we could do this is we could multiply this all out, x plus y 4 times in a row. So that's a lot of distributive property, a lot of foiling, a lot of everything. That's going to take a lot of time. So this idea, this binomial theorem with Pascal's triangle, is a little bit of a shortcut. So where does this triangle come into play? Well, you can say there's a 1, there's a 4, there's a 6, there's a 4, and there's a 1. Those coefficients are Pascal's triangle. And that's really how it starts. It starts with those coefficients from Pascal's triangle. All right. Some patterns, the rules that you might see as we go through. The number of terms is always going to be 1 more than whatever row number you're on. So if I know this is to the power of 5, there should be 6 terms altogether. The first and the last term will always be whatever that value is to the power of the starting amount. So if it goes to the 5, I'm going to say the first would be x to the 5th, the last one would be y to the 5th. My exponents of x, my exponents of the first term decrease by 1 every single time. So I start off with x to the 5th, then x to the 4th, and x to the 3rd. My powers of y, my exponents of y, are going to start at 0 and increase by 1 each time. So y to the 0, y to the 1st, y to the 2nd, until I finally get to y to whatever it might be. In this case, y to the 5th. And then each term's degree, this is the important one, is always going to add up always going to add up to the original amount. So if I see like 10x cubed y to the second, these exponents right there, 3 plus 2 add up to 5. That's a nice little checkpoint. Do your exponents add up to the original exponents? And your coefficients are symmetric. That's Pascal's triangle. We could draw a big old vertical line right through the middle of it, and it would be a mirror image of each other. That's nice to know. All right, so let's try it with an example. X minus 2 to the power of 5. If this is to the power of 5, I need row 5 of Pascal's triangle. And if you don't have that memorized, that's quite all right. I don't either. You can always duplicate it real fast by starting with a 1, then a 1, 1, then a 1, 2, 1, 1, 3, 3, 1. And you just add in between each time you go down. 1, 4, 6, 4, 1. That's row 4. I want row 5, so I got to go one more. 1, 5, 10, 10, 5, 1. And that's the row that I need. So that's what I'm going to start with. I'm going to go with 1, 5, 10, 10, 5, 1. I'm going to write those kind of large. And what I do is I make 6 little mini triangles. And what do you mean by that? What do I mean by that? Take a look at this first guy. This is an X. So I'm going to do underneath this first one, I'm going to put X in parentheses to the power of 5. And then over here is this 2. I'm going to include the sign, make it a negative 2. And I'm going to put that in parentheses as well, negative 2, but I'm going to make it to the power of 0. So you can see the exponents. 5 plus 0 is 5. That's what I want it to be. Awesome. Now let's go to this first 5 over here. I'm going to put the first thing in pink circled there, X, but I'm going to put that to the power of 4. And then this negative 2 also goes in parentheses. And I'm going to put that to the power of 1. 4 plus 1 equals 5. All right, do the next one, the 10 now. I'm going to go in parentheses, X to the power of 3. And then this blue guy, negative 2 to the power of 2. 3 plus 2 is 5. All right, the next 10 right there, I'm going to go X to the power of 2. Notice I'm decreasing my exponents by 1 each time. 5, 4, 3, 2. All right, and then the negative 2 in blue, take a wild guess of what exponent's going to be. You got it, to the power of 3. Add the 2 and the 3 together and you get 5. All right, 2 more to go. I've got X to the power of 1. And I'm going to have negative 2 to the power of 4. And this last one is going to be an X to the power of 0. And a Y, or not a Y, a negative 2 to the power of 5. All right, so I've done that. Now I've just got to do a little bit of multiplication to figure out what's going on here. Well, negative 2 to the 0, anything to 0 is always going to be a 1. So I multiply these 3 things together, kind of like a little mini triangle like I mentioned. 1 times x to the 5th is just going to be x to the 5th. Okay, so then I look over here, x to the 4th, not really going to do much with that. Negative 2 to the 1st is a negative 2, so I can multiply these guys in this triangle together. Negative 2 times 5 is a negative 10, x to the power of 4. All right, making sense. Look at this guy. Negative 2 squared, negative 2 times itself is going to be positive 4. 4 times 10 is 40, so this is plus 40x cubed. All right, look at this next one right here. Negative 2 cubed is a negative 8. So negative 8 times 10 is a negative 80, and that's x squared. Over here, I've got negative 2 to the 4th. Negative 2 times itself 4 times in a row is a positive 16. And then I think a 16 times a 5 is actually going to be a positive 80 times x to the 1st, which is just times x. And this last little triangle over here, x to the 0 is 1. Anything to the 0 is always 1. And a negative 2 to the power of 5 is a negative 32. So negative 32 times 1 is negative 32. And that is the binomial theorem expansion right there. It should be a little bit faster than having to take x minus 2 5 times in a row. Now let's try it with an even more challenging example, and that's this guy right here. I need the third row of Pascal's triangle. If you forgot what it was, the third row of Pascal's triangle is 1, 3, 3, 1. All right, and then I've got to take this first guy is 2x. So underneath that 1, I'm going to put a 2x to the power of 3. And then the second guy over here is a negative 3y squared. So I got to put a negative 3y squared to the power of 0. All right, let's expand this next one. This 3, I'm going to put a 2x to the power of 2, and then the negative 3y squared is going to give me to the power of 1. All right, this next 3 is going to give me a 2x to the power of 1, and this negative 3y squared gets the power of 2. And then finally, I've got a 2x to the power of 0 and a negative 3y to the power of 3. Notice all of my exponents always add up to my original exponent of 3. And now I got to calculate this a little bit. I say 2 cubed is an 8. So this would be an 8x cubed. And anything to the power of 0 is a 1. So this first chunk, 1 times 1 times 8x cubed, would just be 8x cubed. All right. Next one, 2x squared. They both get a power of 2, so that's going to be a 4x squared. Negative 3y squared to the power of 1 is a negative 3y squared. And now I have to multiply this together. 4 times negative 3 is negative 12, and negative 12 times 3 more is negative 36. This is negative 36 x squared y squared. All right, over here, 2x to the first, they both get to the power of 1, so that's a 2 right there, x. And then negative 3 squared is a positive 9. Y squared squared is y to the 4th. And then I have to multiply these coefficients together. 2 times 9 is 18. 18 times 3 more is 54. So this is a positive 54 x to the first, y to the 4th. And this last chunk over here, anything to the 0 is always a 1. Negative 3 cubed, negative 3 times itself 3 times in a row is a negative 27. And then, ooh, I forgot a y squared there. I'm sorry about that. That should be a y squared. Y squared cubed is y to the power of 6. I multiply those exponents together. Then I multiply negative 27 with the 1 and the 1. I get a negative 27 y to the 6th. And that's my binomial expansion. It's supposed to be a time saver once you figure out how this little trick works with Pascal's triangle. Otherwise, you got to do a lot of multiplication, a lot of foiling over and over again. All right. Feel free to jot down any questions you have. Come prepared next time in class, and we'll see you next time. Bye-bye.